Today we're going to be talking about the substitution method, and more specifically the substitution method when it comes to linear equations. Now I want to preface this with what a linear equation is, just in case you don't know. A linear equation follows the form of y equals mx plus b. And what we want to pay attention to in this case is the idea that we're using the y variable and the x variable when solving two equations. I only want to deal with the linear equations today because as you work with more complex equations, more variables, there's more factors that you have to pay attention to, and that can get slightly confusing, but working on linear equations is a first great step. So I think a great way to start when talking about solving these linear equations together would be understanding what we're actually doing. So when we're looking at this first equation, we have 4x plus 2y equals 20. Now we can rewrite that to make it fit the y equals mx plus b equation. We can say this equals 2y is equal to, let's see, negative 4x plus 20. And then this would go to y equals negative 2x plus 10. And then we already have it in the form for the second equation, which is y equals 6x plus 5. So now let's draw that on a graph, just to see what this looks like. So for y equals negative 2x plus 10, say we start at 10 here. We're going to have a slope of negative 2x. So let's go infinitely in both directions. Now let's say we have 6x plus 5, start at 5, which would be about here. And then 6x is going to be steeper slope. Say that's about it. What we're finding when we're solving these two linear equations is the point of intersection. So this is the point that these two lines will be the same, or the point that they intersect where they'll meet each other. So one of the methods we can use to solve these equations is known as the substitution method. And all that's saying is that given our two equations here, so we got equation 1, equation 2, we're going to find a variable for one of them, rewrite it so there's a variable, and plug that into the other equation in order to find the points that they meet each other. So there's truthfully no better way to explain it than just to write it out. So we have 4x plus 2y equals 20. We have y equals 6x plus 5. So I'm going to call this the first type of equation that you're going to see. There's two types. In this case, one of the variables is simply given to you, and that's why I call it type 1. All you have to do is plug it in. It's a lot easier. So let's work on that, see how that turns out to be. So we know that y is equal to 6x plus 5. So what we're going to do, we're going to plug this y into the y of that first equation. So doing that, we're going to have 4x plus 2 times y. We're going to say y is the second equation because we have y equals 6x plus 5. And then that's equal to 20. So solving for that, we're going to have 4x plus 2 times 6x, which is 12x, plus 2 times 5, which is 10. That's all equal to 20. Add these x's together. 4x plus 12x is 16x. So 10 on this side, 20 on the right. We're going to subtract that 10 to get rid of it from the left side, bring it to the right. So then we have 6x equals 10. So x will be equal to 10 over 16, which is the same thing as saying 5 over 8. So now we have the x value, and what that's going to look like on here is this is where the x meets. So x is 5 over 8 right there. So that's the x-axis, the point on the x of the xy coordinate plane that they're going to meet at. And now, with having the x in mind, we can plug it back into the equation to solve for y. Now, since we're solving both of these equations, we know they're going to be the same at the x point. They're going to have the same y value. So we can choose which one seems easier between the two. And out of my opinion, y equals 6x plus 5 seems a lot easier than the other equation to solve for y. So now we're going to plug it back into that second equation, which we have y equals 6x plus 5. And we said that x is 5 over 8, so y equals 6 times 5 over 8 plus 5. Solving for that, 6 times 5 over 8 would be 30 over 8 plus 5. can simplify this. 5 is also the same as saying 40 over 8. And those two, we got 70 over 8. And we could simplify that further and say that's 8, and then we're going to have 6 over 8 left. Same thing as saying 8, and let's see, 3 over 4. So we solve for y now. So we know that the y is falling vertically here. We're going to draw that point right there. 8 and 3/4. So a mixed fraction, but it just makes a little more sense when putting it onto the plane. So now we have the x value and we have the y value. We can say at this point right here is 5 over 8 and 8 and 3/4. So what we did right there, we found a variable that we could plug into one of the equations, got one of the variables as a result of that, found the value of it, plug that value back into either of the equations to find that other value. So that's the first type that you're going to see. Second type tends to be a little more confusing when you're first looking at it. I mean, just by starters, just seeing it, it seems to be a little more confusing. But we're going to take it step by step, just like the last problem. So a good first impression I would do, especially for educational purpose, is we're going to rewrite it in form of y equals mx plus b, just so we can understand what we're doing here and what it looks like. So we can say that this is equal to, let's see, 4x equals 5 plus y, which goes to y equals 4x minus 5. And here we can say 4y equals 18 minus 2x. And that's going to go to y equals, let's see, 18 over 4 minus 1/2 x. So keeping this in mind, we can draw out the two lines that we now have. So we know that this top one is going to start at 18 over 4, which is about 4.5. It's going to have a slope of minus 1 over 2. So let's say that's that first one. And then looking at the second equation, we're going to start at -5 as that's the y-intercept. We're going to have a steep slope of 4. Say it falls like that. And now we're going to solve these to find the point of intersection, which will be right here. We're going to get an x value and a y value as a result. So when looking at this equation, this is the type 2 equation that we're going to be seeing. Let's keep in mind of what we did on the type 1. The type 1, we had a y value that was given to us. Realistically, you can solve for, you can x and then plug that in to find the other variable, or you can have y just like the first equation, first example that we saw, and plug that in to find the other variable. Either way, it doesn't necessarily matter. This one, it seems like y might be easier just because it's kind of already solved for you. So we're going to do that. So let's rewrite these equations. We have 2x plus 4y equals 18. And then we had 4x minus y equals 5. So I'm going to rewrite that bottom equation. So we have y. So we can bring y to the right to make it positive. So then we would have 4x equals 5 plus y. We want the y by itself, so we're going to minus 5 from the right to get to the left. 4x minus 5 equals y. So now we're back to type 1. We already have the variable solved for us. We have y equals 4x minus 5, and we can plug that into the first equation to help us solve for the other variables. So let's do that. So continue with this. Plugging that y into this first equation, we have 2x plus 4y. We're saying y is equal to 4x minus 5, and then set that equal to 18. Solve this out, so we got 2x plus 16x minus 20 equals 18. Okay, we can add these x's. 2x plus 16x is 18x. And then we know we can add this 20 to get to the right side. 18 plus 20 is 38. So x is equal to 38 divided by 18. Same thing as saying 19 over 9. Which is also the same thing as saying 2 and 1/9. So now we have our x solved for us, so we're going to plug it back into which equation seems to be easier and find a y. I'd still say that second equation is easier just because you have a single y by itself, which is what we're going to want at the end. So let's plug that x in to find the second point of intersection. So this will be the x point of intersection, which we can just write 19/9 up here, or 2 1/9 also works just fine. And we're going to plug it into that first equation to find the y point of intersection. So say we got 2, we're going to plug in x, which we know is 19/9. And let's actually plug that into the second one. It's going to be slightly easier. 4 times 19/9 minus y equals 5. So in this case, we're solving for y. That's why we picked the second one, because we have y all by itself. 4 times 19, that's going to be 40, plus 36, 76/9, and then minus y equals 5. I want to get y by itself. 76/9 equals 5 plus y. And now we're going to want to subtract 5, and we'll rewrite that, but that's the same thing as saying 45/9 plus y. And now we can finally solve for y here. So 76 minus 45 will be 31, and that's going to be over 9. It's equal to y. And this is the same thing as saying, let's see, 3 and 4/9. So y is equal to 31/9 or 3 and 4/9. Well, we'll write 31/9, just keep it consistent with the other one. And now that we have both of those, we have the point of intersection. And that'd be 19/9 for the x, and y would be 31/9. So when it comes to solving two linear equations, this is the first method we can use. It's called the substitution method. I'll have a video on the other method, which is called the elimination method. Tends to be easier in some situations, but this gives a good understanding of how manipulating variables can work. You can plug them into one equation to force it to equal the other equation. When it comes to linear equations, like we're using here with x and y variables, we're simply finding the intersection of two different lines. Beyond that, it doesn't have to be more complicated. Just practice problems, and I'll be more than enough to help you solve these for your test. But yeah, beyond that, it shouldn't be any more difficult. Let me know if you have any questions. Feel free to comment, like, subscribe, share those videos with your friends. Love to see that. Otherwise, I'll see you guys in the next video.